Last episode, we watched a system guess a hidden pattern and get better round after round. But we deliberately didn't open the hood. Today we do. What actually happens, mechanically, when a machine learns? By the end, you'll be able to explain training, loss, and parameters, the three words underneath every model that has ever existed. This is the episode where the vocabulary stops being abstract. Once you see exactly what a parameter is and what loss actually measures, every future video on this channel, no matter how advanced the model, will reduce to this same mechanism. Forget the jargon for a moment. Just watch a tiny model try to fit some numbers. Here's the entire dataset. When x is 1, y is 10. When x is 2, y is 20. When x is 3, y is 30. There's an obvious pattern here, but the model doesn't know it yet. Its whole job is to find one number that predicts y from x. That one number has a name, a parameter. Let's call it w. The model's prediction is simply w multiplied by x. Right now, nobody has told it what w should be, so it starts at a random guess. Say w starts at 3. 4x equals 1. The model predicts 3. The real answer, from our data, is 10. That gap, the distance between the prediction and the real answer, has a name too. It's called the loss. Right now, the loss is 7. One number, summarizing exactly how wrong the model is. Quick prediction, before I show you what happens next. Does the model fix this in one giant leap straight to the right answer, or does it take several smaller steps? Step 1. The parameter moves from 3 to 6. Loss drops from 7 to 4. Step 2. The parameter moves to 8.5. Loss drops to 1.5. Step 3. The parameter moves to 9.8. Loss drops to 0.2, barely there. One more step, and the parameter lands on exactly 10. Loss, 0. Watch that number across every step. 7, 4, 1.5, 0.2, 0. That descending line is the loss curve, and shrinking it is the entire goal of training. Let's name what we watched properly. Training means repeatedly adjusting the parameter to shrink the loss. Nothing more mystical than that. A parameter is an internal number the model owns and adjusts. In our example, exactly 1. In a real model, there can be millions or billions of them, but each one plays the exact same role. Loss is a single number that measures how wrong the current parameters are. No loss number, no way to know which direction to adjust, and no training at all. Here's the general shape underneath it. Predict, using the current parameter. Measure the loss. Adjust the parameter to reduce that loss. Repeat. Quick honest note. Real training uses calculus to know exactly which direction and how far to move. What you watched is a conceptual visualization of the result, simplified, not the literal computation. Let's break it on purpose. What happens if each step is too big? Watch. The parameter jumps from 3, straight to 17, overshoots badly. Corrects to -2, overshoots the other way. Bounces to 19. It never settles. This step size has a name, the learning rate. Too large, and the model overshoots forever instead of converging. Here's a trickier case, on purpose, because a good mental model has to survive an attack. What if the real pattern isn't a straight line? Can one parameter still learn it, no matter how long we train? No. Watch this new dataset, the true relationship curves. No matter how we adjust our single parameter w, the loss gets small but never reaches 0. It's stuck. The model structure, not its training, puts a hard ceiling on what it can ever learn. More training cannot fix a model that is structurally too simple for the pattern. This exact mechanism, parameters, loss, repeated adjustment, sits underneath pricing models that estimate what you'll pay, ranking systems that decide what you see first, and every large language model you've ever used. The scale is different. The mechanism is not. So, to recap, using the same shape we'll reuse across this whole channel. Problem: what actually changes inside a model when it learns? Mechanism: repeatedly adjusting internal parameters to shrink a measured loss. Result: a one-parameter model can find a straight line pattern in 4 small steps, with nobody handing it the answer. Limitation: step size matters. Too large, and it never converges, and no amount of training can fix a model whose structure is fundamentally too simple for the pattern. Which leaves us with the next real question. Once a model has learned something, where does that knowledge actually go? It's not stored as a sentence anywhere. So where, and in what form? That's exactly where episode 3 goes. Training, loss, parameters. You now actually understand the mechanism, not just the words. Follow AllAboutAIVerse. And let's keep going, one honest idea at a time.